Right, so the first example that I want to look at is with linear programming, and students oftentimes have a hard time setting these problems up, but oftentimes once they're set up, they're not that hard to do. It's kind of what I found. So I'm going to read the problem and kind of show you how I think through this. First of all, okay, it says a manufacturer of lightweight mountain tents makes a standard model and an expedition model. Generally, there's going to be a couple of things going on here. Each standard tent requires 1 labor hour from cutting and 3 from the assembly department. Now, I'm going to highlight that because that's important information right there. All right. Then it moves on and says each expedition tent requires 2 labor hours in the cutting department and 4 from the assembly department. So that's saying a similar thing to the last sentence. Then it says the maximum labor hours, and that's a real key. When you see that maximum, that's part of what you're working with. It says in the cutting department and assembly department, 32 and 84 hours respectively. So what I just highlight is probably your constraints. And it says if the company makes a profit of $50 on each standard tent and $80 on each expedition tent, how many tents of each type should be manufactured each day to maximize the total daily profit? Okay, so here's the way I kind of look at this after I start reading this. The first thing I'm going to always do is figure out the variables. Now read the question, and that will tell you what your variables are. So what it says is it says how many tents of each type must be manufactured. So that's the key right there is let's go ahead and do our variables. So we're looking for how many of each type. So we're going to say X is the number of the first type of tent, which is standard tents. Okay, and then the second thing would be another variable I'm going to call Y is the number of the expedition tents. Okay, so you get that figured out. Okay, now I'm going to go on to the objective function. The objective function is what you're optimizing. Okay, and what I mean by that is the idea is what are you maximizing? So what it says here is you're maximizing total profit. Okay, so I'm going to write an objective function. I'm going to use P for profit. And what it says is you make $50 on a standard tent. A standard tent is represented by X. So if you had 10 tents, 10 times 50 would be $500. Okay, then it says $80 on an expedition tent, which is Y. So if you sold 5 expedition tents, 5 times 80 would be $400 you profit. So this is what you're going to plug corner points in. Okay, as we're going through this, the corner points of your feasible region get plugged in for X and Y. All right, now the constraints is all this stuff that I have highlighted here. Okay, so it says basically when you read this, and I'm going to write this down kind of at the side here. So it says if you have an expedition, or let's start with the standard tent. Okay, standard tent kind of goes like this. Okay, it says 1 hour cutting. And sometimes you just write stuff down on scratch paper. And then it says 3 hours for assembly. Okay, so that's important information. Okay, then the stuff I highlighted in green is the information for expedition tent. That says 2 hours for cutting. And then it says 4 hours for assembly. Okay, so we got that. Now what's going to happen is it says the cutting department, you have 32 labor hours available. So cutting, I'm just going to write that down, is 32 hours available. You don't have any more than that. And then it says you have 84 hours available for the assembly department. So putting this information together along with the variables is going to be what the constraints are. Okay, so here's the way I look at this. I kind of look at it like Okay, we have a standard tent, which is X, an expedition, which is Y, and we have this stuff for the cutting department right here. Okay, that's your information. That's an equation or an inequality right there. So we would say 1 hour for a standard tent, which is X, plus 2 hours for an expedition tent, which is Y, is less than or equal to the 32 hours that are available for the cutting department. Okay, and then the other thing it says, it starts putting together all this information about the assembly department. Same idea. So what we'd have is 3 hours for a standard tent, 4 hours for an expedition tent, and no more than 84 hours available. So those are your constraints. The other thing is X and Y both have to be positive numbers because they represent the number of tents. So this is the hardest part of the problem right there, is figuring out those constraints in that objective function. What I recommend is figure the variables out. That's easy to find. You read the question. The question will tell you what your variables are. Okay? The optimizing objective function, it's going to say maximize profit, maximize cost, minimize something. Okay? And then that information should be put in the problem. Now, once you get this all put together, then what we're going to do is we're going to graph these inequalities. So we have the first inequality is X plus 2Y less than or equal to 32. The best way to do this is just find the x-intercept and to find the y-intercept. Okay? And you can do this in your head, but the way that we learned how to find an x-intercept is let y be 0. So you'd have x plus 2 times 0 and just set that equal to 32. So that's x equals 32. Okay, so we would end up having an x-intercept there. For a y-intercept, you let x be 0. So it would be 0 plus 2y less than or equal to, or set it equal to, 32. Okay, you can do that in your head. That would be 16. So you would get the y-intercept is 16. Okay, so that'll kind of give us an idea of how to scale this thing out. Now I'm going to go ahead and go to the next equation, which is 3x plus 4y less than or equal to 84. Again, we're going to find the x-intercept and we're going to find the y-intercept. Okay, same idea. You can do this in your head if you want to. X-intercept, let y be 0. So it would be 3x plus 4 times 0 equals 84. Solve this equation. Okay, you can divide by 3. You can use your calculator to figure this stuff out if you want to. So 84 divided by 3 is going to give an x-intercept of 28. Okay, so we got that piece of information now. Then we're going to do y-intercept. Let x be 0, so that would be 3 times 0 plus 4 times y equals 84. That's 4y equals 84. Divide by 4. You're going to get what this is. So 84 divided by 4, I think, is 21. Okay, use your calculator to get those things figured out. Okay, now after I get my x and y intercepts, that gives me a good idea of how to scale my x-axis and y-axis. The biggest x-intercept is 32, so I'm going to go out to 32. The biggest y-axis intercept is 21. So it doesn't really matter how you do this. I'm going to go something kind of like this. I'm just going to go by 5s and label it 5, 10, 15, 20, 25, 30, 35. Okay, like that. Okay, that's the x-axis. And then I'm going to do about the same on the y-axis. I'm going to make it go a little bit bigger. I'm going to go like every 3 is 5. 5, 10, 15, 20, and 25. Okay, that's kind of up to you, but it's kind of good to draw big. So what we're going to do is we're going to graph these. I'm going to graph this in like red. Okay, so this first inequality, I'm going to go to an x-intercept, 32, just approximate it, a y-intercept of 16, and then we will go through. It's a good idea to take a straight edge or something and draw that accurately. So that's going to go like that. Okay, Okay, and that's going to be less than. That's less than, so I'm going to make an indicator to myself that I'm below that region as I go through that then. Okay, then I'm going to pick like another color, let's say like green, and I'll do this. Okay, so I'm going to do green, and I'm going to get these plotted. So I have an x-intercept of 28, so I'll approximate that, y-intercept of 21, and then I'll connect those two things into a straight line. It's not a bad idea to use a straight edge so that you're pretty accurate. And the idea would be you're under that at the same time. All right? Now what happens is also this, x has to be bigger, has to be positive, y has to be positive. So where you are is you're below both of those lines, and you're above and to the right of the y-axis. Above x, to the right of y. So this is what you call your feasible region then, like that. And then we got to think about what the corner points are, okay? So next thing we're going to do is determine the corner points. And a lot of this can be done, either you can observe what it is, or you can use a matrix, okay, on your calculator, which we'll need to do probably for one of those. So actually, this is a quadrilateral. It's got 4 corner points. Okay, those 4 corner points are going to be these values. Okay, that's a corner point, 0, 0. Okay, this is a corner point there. That's the corner point 0. And then that's that y-intercept of 16. So that's a corner point. Okay, another corner point is this one, which is over 28. See, the x-intercepts are 32 and 28, so that's 28, 0. And then you got this one, and then that one you got to do a matrix on. That's the intersection of your two inequalities. So I'm going to do a matrix on this. So I'm going to go 1, 2, 32. And then I'm going to go 3, 4, 84. And I'm going to put that in an augmented matrix. Now in this table, I'm just going to write all my corner points out. So I got 0, 0, which isn't going to be the maximum, obviously. You don't have to do anything with that. You have 0, 16, which is important to test. 28, 0, which is also important to test. And what we're going to do is this is your corner point, and then we're going to look at the profit, and we're going to see which one is the maximum profit. Okay, so I'm going to put this in my graphing calculator, so on this matrix, because you don't need to do that by hand. You can do that by hand if you want to. So I'm going to go to, on a clear screen, I will go second matrix, edit. I'm going to put this in matrix A, and the size of this matrix is it has 2 rows and 3 columns. Okay, put in the information, 1, 2, 32. Second row would be 3, 4, and 84. Okay, like that. And then go to a clear screen. You can go quit, back to matrix, and then go to math, and then search for the reduced row echelon form, which is here. Type enter, go back to matrix, highlight A and put that in, and then that will do that for you. So what that gives you then is this gives you 1, 0, 20, 0, 1, 6, which means this corner point right here, that corner point right there is going to be the point 26, which looks like a pretty good value then. So we're going to write that down as 26, and then when we have that corner in the feasible region, we're going to plug that into the profit function. Okay, so now the profit function is up here. So I'm going to write that down. And we're going to plug in the corner points, and we're going to find which one is the biggest then. The 0, 0 is not really necessary because that would give you 0 profit. So at 0, 0, you can bypass that. That's 50 times 0 plus 80 times 0. That would be a profit of $0. So that's obviously not it. But you do got to test the rest of them. 0, 16, test that. You would have 50 times 0 plus 80 times 16. So you want to do that on your calculator. Okay, so we do that. That's just going to be 80 times 16. And that will be $1,280. Okay, then test the next one, 28.0. Okay, so you go like this. You will end up going 50 times 28 plus 80 times 0. Work that out. So 50 times 28, 50 times 28 gives you a profit of $1,400. So far, that's the winner. But we got one more to do. So we're also going to do 26. 26 goes like this. You're going to go 50 times 20 plus 80 times 6. That will give the profit on that corner point. So do that. 50 times 20 plus 80 times 6. And that's going to give $1,480. Okay? All right, so that means that this is your maximum right there. That is your maximum profit right there. So what we would say for our answer is we would want to say this. Okay, we would say max profit is $1,480. And then that would mean that you sell 20 standard tents and 6 expedition tents. Okay, that's how you do that. The corner points will always give you where your maximum or minimum occurs. So that is your answer right there. Okay, that's linear programming. The hardest part is getting that set up. To set it up, start with the variables. The variables come from the question. Okay, the objective function is always what you're maximizing or minimizing. The constraints will be about things like at least, no more than, things that involve inequalities. Okay, so that's how that goes. All right, that's question number 1. Okay, second thing I want to review is difference quotient. And you can pause the video anytime you need to. So we're going to take a function and work out the difference quotient. The way that this sets up is like this. Okay, I always like to show students to, when you set this up, draw 2 brackets and the whole thing's over h. Okay, f of x goes here. Okay, f of x is always what you're given. Okay, so that goes there. Just drop it in as it is. Okay, f of x plus h is the same thing, except where you see an x, replace that x with x plus h. So it'll be the same thing. It'll be x plus h squared instead of x squared, minus 4 times x plus h, minus 2. So there's 2 parts of this problem. The first part is getting that mostly set up, and then the next part of that would be simplifying that then. Okay? So I'm going to do a few things on scratch paper. The first thing I'm going to do is I'm going to do this. All right? And if you want to do x plus h squared, the best way to do that's just kind of on scratch paper, write it out twice, and then do the FOIL. So if you do that, you would have x to the second for the first term, plus xh for the outside term, plus another xh for the inside term, plus h squared for the last term. You got like terms. These 2 things right here are like terms. There's a total of 2 of those. 1 plus 1 is 2. So that's x squared plus 2xh plus h to the second. All right, now I'm going to move this over here and then we're going to finish this up. Okay, so what we'll end up having is we'll have that part right there is x squared plus 2xh plus h squared. Okay, this part here is minus 4x minus 4h there when I do the distributive property, minus 2. This part you got to distribute the negative through to get minus x squared plus 4x plus 2 all over h. So that's the key to the problem, is getting all of that multiplied out, not missing signs. You're going to notice on here a whole bunch of things cross out. The x squared minus x squared goes to 0. The negative 4x and x goes to 0. The negative 2 and 2 do. So you're left with these terms, which all have an h in them. Okay, so what we'd have then is 2xh plus h to the second minus 4h over h. Now you can either divide it up or you can factor out an h. It doesn't make any difference which way you do that. I'm going to take an h out because there's an h in every position. So when I take that out, I'll have an h times 2x plus h minus 4 all over h. Now the h's divide out, and then that is your answer of the problem. So the answer would be 2x plus h minus 4. Okay, those problems always work out pretty much about the same way. Okay, so that is your answer right there. Okay, so you want to get that, know how to set that up well. Okay, next thing I'm going to review is graphing functions for a little bit. So we're going to graph this function, and then we're also going to graph this transformation. Okay, so the first thing I'm going to do is over at the side, I'm just going to make a table of values, and you can also use your graphing calculator on this. X and y equals x squared. So I'm just going to use some standard values, -2, -1, 0, 1, and 2 like that. And all I'm doing is squaring these. So 2 to the second's 4, 1 to the second's 1, 0 to the second is 0, and then you're doing -1 to the second, which is back to +1, and -2 to the second is +4. Now what I'm going to do is I'm going to graph these points, and just kind of use a dashed line. So -2, 4 is a point, -1, 1 is a point, 0, 0, 1, 1, and 2, 4. Okay, then that will be the graph of y equals x squared. Okay, now I'm going to do transformations. So you got to know these things. This right here is inside the function. It's a plus, so that would be left 1. This is outside the function. It's a minus, therefore that would be down 3. The number in front, think of that as multiply y by -2. Now you can do this without a chart or with a chart. It's up to you. What I'm going to do is I'm going to write down the 5 key points I have: -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, then I'm going to make a table for this. Okay, and you have to do this in order. You have to do the left, then the multiply, then the down. You're following order of operations. You're working inside parentheses, then multiplying, then subtract. So step 1 is to take all of these points and move them to the left 1. Then, in step 2, multiply y by -2. All of this you can do in your head. And then the last step is to go down 3. Okay, if I want to take everything left 1, that means all of these x values need to get smaller by 1. All of the y values will stay the same though. Okay, so as I write this next step, what I'm going to do is just leave the y values alone. That's 4, 1, 0, 1, and 4 like that. They stay the same. Now in your head, just do this. -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. So we have that. Okay, now we go to the next step, and the next step you're going to take all of these y values and multiply them by -2. Okay, so we'll do this. So the x values, we've got those transformed. So I'm just going to bring those things down. Now in your head, multiply these by -2. 4 times -2 is -8. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. 4 times -2 is -8. Okay, we got one more thing to do, and that would be moving everything down 3. So if we move the points down 3, that would mean the y values get smaller by 3. So these x values are set. So just rewrite them. Now, in your head, all these go down 3. -8 minus 3 is -11. -2 minus 3 is -5. 0 minus 3 is -3. Negative 2 minus 3 is negative 5. And negative 8 minus 3 is negative 11. So this kind of gives you your points right here. That's what you're looking for, is those points. Now we're just going to plot these points and we'll be done. So negative 3, negative 11. Okay, I'm just going to move like that. I'm out of room. I'll just put a dot there. Then negative 2, negative 5. Negative 1, negative 3. I've got 0, negative 5. And over 1, down 11. So that would be what that final graph looks like, is like that then. Okay, so all of the points have been transformed. So it goes like that. All right, so that's the final. All right, so you want to know how to do that. Now see, that kind of a problem right there, you can do the graph of y equals x squared on your graphing calculator. And, you know, if you wanted to bypass that table, you could go like this. You could go y equals x squared, go zoom 6 to graph. And if you want to get those points, you could go second graph to get a table. So you get the points negative 2, 4, negative 1, 1, and so forth. But you have to figure out the transformations. Okay, and you can't do those transformations on your calculator. Okay, the next one you could also do on your graphing calculator. But first of all, on this, when you have a square root, what's under the radical has to be greater than or equal to 0. So when I do this, my table, I'm going to have x and y equals square root of x. I'm going to start with 0, and I'm going to pick numbers I know square roots of. So I'm going to pick 1, 4, and 9, and do this like this. So I just do square root of 0, which is 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is going to be 3. And then I can graph this then. So I got the point 0, 0, 1, 1, 4, 2, and over 9 up 3, like that. Okay, now remember, you got a graphing calculator, so you can check this pretty easily. You can just go y equals square root. Whoops, you want to clear that first. Square root, you go second x squared, put in x, zoom 6 for a standard window. There you have it, and see your table of values is there for you. And you're going to get errors when you have negative numbers. So you got 0, 1, 1, 1, or 0, 0, 1, 1, 4, 2, 9, 3. They're all there, okay? And I'm just using good values so I don't have to worry about decimals. Okay, here's another graph. Okay, so this, again, table of values. I'm going to use negative 2, negative 1, 0, 1, and 2. And I'm just doing the absolute value. So absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of a positive remains positive. So you get those values. And then this is just a matter of graphing this. So it's left 2, up 2. Left 1, up 1. 0, 0. 1, 1. 2, 2. And then your graph on an absolute value like this has that V shape. So what you want to basically make sure that you know how to do is how to make a table values and graph a basic function. Then you want to be able to do transformations, kind of like I did on 3A. You could do transformations on any of these graphs by making a table. Okay, so you want to review over how to do that. Okay, the next thing I'm going to look at is a quadratic function. And we're going to look at finding the vertex, the intercepts, figure out if it opens up or down, whether it's got a min or max. Okay, so first of all, what you want to kind of remember on this basically is a quadratic function looks like this. It has the structure ax squared plus bx plus c. And basically, if a is a positive number, its parabola goes up. So it would kind of look like that. If a was a negative number, then it would go down. And then the vertex, you use the formula negative b over 2a. So that's what we're going to do in this case. So it goes like this. Basically, in this problem, a is equal to 1. B is equal to negative 2. And then C is equal to negative 8. A is the number in front of x squared, B is the number in front of x, C is the constant number. So when we do the vertex, and let's go ahead and do it, opens up because A is positive. Okay, so that number in front of x is a positive number. So the vertex, we're going to do negative b over 2a. So b is negative 2, so we do negative 2 all over 2 times a. A is 1. A negative 2 is 2, so 2 over 2 would be 1. So that means the x value of the vertex is going to be 1. Okay, then you got to find the y value. So what we do is we evaluate this function at 1. So I'm going to replace all of the x's in the function with 1. So I'd have 1 to the second minus 2 times 1 minus 8. So that would be 1 minus 2 minus 8. That would be 1 minus 10. That would be negative 9. So your vertex is 1, negative 9. And I'll show you how you can check all this on the graphing calculator here in just a minute. So what you'd want to do is you'd want to go ahead and graph that. So go over 1, down 9, and that will locate the vertex for you. Okay, so that's our vertex. Generally what you have on a quadratic, you don't necessarily have to put that, but we have what we call an axis of symmetry. And that just means the quadratic function's graph is symmetrical about that vertical line. Okay, now let's find the intercepts. Okay, so the way you find an x-intercept is you set the function equal to 0. Okay, and this will require some factoring. So take the function x squared minus 2x minus 8, set that equal to 0, and then factor that. Okay, first term is x and x. Last term, look for numbers that multiply to give 8 that add up to 2. That's going to be 4 times 2 gives 8. And if you want 4 and 2 to add up to negative 2, you're going to have a negative and a positive like that. Okay, if you factor something, FOIL it and make sure it's right. Okay, from here, you can pretty well do this in your head. You solve that equation and you solve this equation, that will give you your x-intercepts. So this one, you can add 4 to both sides or do in your head. That's x equals 4. This one, you can subtract 2 from both sides or do in your head, you get x equals negative 2. So your intercepts are the points 4, 0 and negative 2, 0. Okay, like that. So I'll go to my graph and I'll locate 4, 0. I'll locate negative 2, 0, and then that gives the 2 intercepts. Okay, if I want to find a y-intercept, then what you do is you set x equal to 0. So in other words, you do f of 0. So go up to the function. You would do 0 squared minus 2 times 0 minus 8. Work out the details. That gives negative 8. So your y-intercept would be the point 0, negative 8. Okay, so I'm going to put that on there, and that's good enough for graphing. Now what happens on a parabola, one thing I showed you is you got the vertex, and this only works if there's nothing in front of x squared, then you can go over 1 up 1, or you can do this, you can go over 2 up 2 to the second, or you could go over 3 up 3 to the second because it's a squaring function. So you can do this if you want to. You could go over 1 up 1, over 2 up 1, 2, 3, 4. It just gives you greater accuracy, and then that's good enough. Same thing here, left 1 up 1, left 2 up 1, 2, 3, 4. And let's see, I think I got that point wrong. It would go like that, and then just connect the dots. Okay, now this problem right here is 100% checkable on your graphing calculator. In fact, you can get all this information from your graphing calculator. So if you do y equals, plug in the function, we did x to the second minus 2x minus 8, graph in a standard window. So if I go zoom 6, that gives the same thing. Now you can look at your table of values. You can tell it's opening up. Pardon me. Okay. So what I was going to show you is once you get that graphed, you can go second table, second table, and all those points are on there, see. So you've got like 4, 0, that's one of your x-intercepts. 0, -8 is your y-intercept, and then there's -2, 0. So you can oftentimes check and verify your x and y intercepts on the graphing calculator. All right, so that's how it goes. Another thing you can do is this. You can trace at these values. So if I traced at 4, okay, you can tell that's an x-intercept. If you trace at -2, you can tell that's also an x-intercept. And if you trace at 0, that gives you your y-intercept of -8. So they're all 100% traceable and verifiable on a graphing calculator. Okay. All right, so moving to the next page, the next thing I want to go through is just equation of a line. So if you're given a slope and a point, then you should be able to get the equation and graph that then. Okay, so what you do is you use the formula that we call the point slope formula, which is y minus y1 equals m times x minus x1, and we plug in. Okay, so the -2 is an x value, that goes there. -3 is a y value, that goes there. And the slope goes in for m like that. All right, so let's go over how you would do this then. So basically when you plug this in, you would end up having this. You would have y subtract -3 equals -4/3 parentheses x subtract -2. All right, now anytime you see minus minus, what do? You change that to adding a positive. So what we would have is we would have y plus 3 is equal to -4/3 times x plus 2. Now you want to solve this for y. The best way to solve this y, to me, the easiest way, is to get rid of that fraction so you don't have to worry about it. So what I'm going to do is multiply both sides by 3. And if you do that the correct way, you will get rid of all your fractions then. Okay, so the way this works is like this. That would be distributive property. That's going to give 3y plus 9. That's going to cross that out. Okay, don't take the 3 through because it's gone. Now take the -4 through, so you would have -4x and minus 8. Okay, then you can solve for y. So you could subtract 9 from both sides. That would give 3y is equal to -4x, and then that would be minus 17. And if you divide everything by 3, then you should have this solved for y. So that would be y equals -4/3 x minus 17 over 3. So that would be the final answer to your problem right there then. Okay. All right, if you're going to graph this, what we would do is we would start the point, -2, -3, left 2, -3. And if you have a slope of -4/3, that would tell you go down 4 and to the right 3. So from this point, you could just simply go 1, 2, 3, 4 down to the right 3. And then you can sketch in the graph of that if you want to. And then that'll give you a pretty accurate graph. It only takes 2 points to make a line, so that's a pretty nice graph on that. Again, what I did on that is I went down 4, and I went to the right 3. Okay, so you want to know how to do use the point slope formula to find the equation of a line. Okay, next thing I'm going to review is break-even analysis. Okay, in this problem, you're given 3 things. You're given a price-demand equation, you're given a revenue equation, and you're given a cost equation. So basically, break-even, and you're going to do this graphically, and you'll do it with your calculator. Break-even is where the revenue is the same as the cost. And we're going to do this totally on the graphing calculator, okay? All right, so let me show you what I would do on my calculator. So first of all, I don't worry about the price function because the revenue is just x times p. Okay, the price demand, what you do is you multiply that by X to get the revenue. So what I'm going to do is just put this in, X, and you don't have, you can distribute it if you want to. You could distribute and get 75X minus 3X to the second. You can put it in like that, or you can just put it in the way it's given. 75 minus X. Okay, like that. And then put in the cost function, which is 125 plus 16x. Now, the key thing on this problem is you're going to have to figure out how to set up your viewing window and get it effective and everything. So the first thing is on the window, we want to, I'm saying go from 1 to 20. I'm going to go ahead and just do x equals 0 to 20. That's what I'm interested in, and then you can scale that by whatever you want. You can scale by 1, you can scale by 10, scale by 5. I'm going to scale by 5. Now, if you want to know what the revenue is, look at your table of values. So go second table and just start looking at the values of the revenue for these numbers. So look how they're getting bigger as we go to all the way to 20. They're up in the 200s, now they're the 300s. When we get to 20, we're all the way up to 1,100 there for the revenue and 4,500 like that. Okay, now I may have to change that X value a little bit. I may have given you guys a kind of a bad X value, so I'm going to take that a little bit bigger. I think I gave you kind of a bad thing. I'm going to go 50 and scale by 10. And then for the Y, I'm going to go, let's see, I'm going to scale like that. And you got to play with this a little bit too. So I'm going to start at 0, maybe up to 5,000 for the revenue and cost, and just kind of see what this looks like then. Okay, and then I'll adjust it. Okay, that's not very good. My y-axis is way too big, so probably, see, this is going 1, 2, 3, 4, 5,000. So probably if I go up to 2,000 or something like that, I'm probably a lot better. So I'm going to go like this. I'm going to take this out bigger. So I think I gave you guys a bad value there. And then I'm just going to take that up to 2,000 and then scale by 500. And you got to play with it because you want to see the revenue and the cost, and you want to see where they intersect because those two things are the break-even points. So I'm going to adjust it one more time just because it's better. So this is going 10, 20, 30, 40, 50, 60, 70. I'm going to go change this to 80. And that's probably good enough. So let's just go with this. And then, I always do that wrong. Okay, let's see. Okay, that's a little better. Okay, so let's graph it like this, and then we're just going to sketch a graph. Now, you're going to do this basically with the assistance of your graphing calculator too. So what you'd want to do as far as drawing a graph is set up the same way we have the window, where this is X, okay, and this is your Y value like this. So we're going to go to 80, so 10, 20, 30, 40, 50. Be sure that you label what everything is, 60, 70, 80, just enough so I can tell you're going by tens. Then we're going by 500s, all the way up to 2,000. And then you want to get a pretty accurate graph, okay? You don't want to just sketch it without getting any accuracy. See, what you can do on this is it's easy to trace. So if you want to trace this blue function, you can go like this, trace. Right now it's displaying the blue function, so you can type in anything. Like if you want to type in 0, then you get a 0.00. Okay, so what I'm going to do is I'm going to plot the 0.00. 10, 20, 30, 40, let's just try to trace at 40 to get somewhere close to the maximum. So that's 1,400. So you go over 40, up 1,400, about like that. And then this is down, let's see, 10, 20, 30, 40, 50, 60, 70. So it looks like right around there it's back to 0. And then those 3 points gives you a nice accurate graph of the revenue. Okay, so that's the revenue function. you can trace at the cost function the same way. Now that's a line, so if you trace, if you want it to trace the red line, you got to toggle up and down between the functions. Right now I'm on the red line, so if I traced at 0, I would get 125. So I'm going to just estimate that point there, and I'm going to get one more point. I'll go all the way to 80. Trace at 80, and then that gives 1405. So that's somewhere kind of in there. Then you can sketch that out like this. So your break-even points are these two things right here. All right? And the way you do this on the graphing calculator is you go like this. You go, and I'll write down the keystrokes. You go second trace, like this. So second trace, option 5, intersect. Okay, press enter. All right. Now what it's going to do, you can't really see a cursor, so you got to go left and right until you see a cursor. All right. Now let's get this intersection point here first. So get pretty close to it. Press enter. A second curve comes on the line. Press enter again. When it says guess, press enter. So there's a break-even point. We'll just label these things as we go like this. So that break-even point right there is going to be 56.8 and 1033.79. Okay, so that's break-even point number 1. You can kind of round usually to 1 or 2 decimals. 2 decimals generally for the money, which is the Y value. Then I have to start over again to find this break-even point. So I go second, trace again, option 5, and then this time move the cursor over, and you got to keep moving it until it's pretty close to that other intersection point like this. Okay, that's probably close enough. Okay, press enter, comes up again, press enter, press enter. You're going to know you're doing it right because it's blinking on the right point. So then this break-even point right here is going to be 2.2, comma, 160.21. Okay, so those are your 2 break-even points, like that. Okay, so basically, where does loss and profit occur? So basically the way this goes is like this. The area that I'm shading in there is that whenever the revenue is bigger than the cost, that's your profit area right there. Okay, so what you would find is profit is going to occur, and you can just say in words if you want to, between this and this. So it's going to be between 2.2 and 56.8 items. And X is in this problem is memory chips. So I'm just going to say memory chips. Okay. The loss occurs here. So the loss is going to occur in all of the other places right there. Okay. So the loss ends up happening here. So you have loss when X is less than 2.2 and when X is larger than 56.8. What loss means is the cost is bigger than the revenue. Okay, so you want to study the difference between those two like that. Okay, so that's a technology problem primarily. Pause anytime you need to on these. Okay, so next thing we're going to talk a little bit about is matrices and systems of equations and what you do on the matrix. Okay, so I'll give you a couple of examples on this. You can use your calculator on Gauss-Jordan elimination. So here's a system. We're going to write the augmented matrix like we learned. So the first row would be 1, 1, 1. Usually use a dashed line. That's equal to 3. Second one is 2, 3, 7, 0. Third is 1, 3, negative 2, 1, like that. Now that's all you got to write down for the augmented matrix. Now I'll take you through the keystrokes again on this. So the first thing you got to go is you got to go second x negative 1 to open up the matrix command. Then you go to edit is where you're going to put in the matrix. So I'm just going to put this in matrix A. The size of this is 3 rows by 4 columns. So you want to size it. Okay, like that. Okay, so that's going to give 1, 1, 1, 3. Like that. And then the next one is 2, 3, 7, 0. And then the third row is 1, 3, -2, and 1. Okay, so get your matrix put in like that. So that's how that matrix goes in. Then you want to start over again, so you want to quit. Get to a clear screen, then start over again. Go second matrix, go to math, go down until you find reduced row echelon form, press enter. Got to get the matrix stored in, so you go second to get that, highlight the A, press enter, and then that gives you the value like that. Probably not the best example, but they can come out to be decimals and whatever. Okay, so that would be your reduced row echelon form, which has goes like this: 1 0 0 0 1 0 0 0 1, and then this would be your solution. I'm just going to round these values off to 1 decimal, and then we write the answer as a point, usually in order. 5.9 is x1, -2.2 is x2, and -0.8 is x3. Okay, so that's your answer to your problem. Now you don't have to do that by hand. You can do that on your calculator then. Okay, I'm going to do the next one the same way. So what I'll be doing with this one is set up the matrix so it goes 1, 2, -1, 1. And then it goes 2, 2. There's no z there, so that's 0, 1. And then 1, 3, -2, 1. Okay, so we're going to just put this in the calculator. And you can type over whatever you have. So I'm going to clear. I'm going to go second x -1, edit. And I'm going to type over what I already have. This is a 3x4 matrix, so just type over these numbers. So 1, 2, -1. 1 is the first row. Second row is 2, 2, 0, 1. Third row is 1, 3, -2, and 1. Okay, so that's the matrix. That matrix has been put in. We're going to do exactly the same kind of thing with the reduced row echelon form. So I want to quit to go to a clear screen. Then I go second, x -1, math, go down to reduced row echelon form, like that. Second, matrix A. I'll get that put in, and now we're going to write down what we get on this then. So this is the other thing that we learned that can happen. There's a couple of things we learned. This is the other thing I want you to review. So the reduced row echelon form goes like this. And the thing is, because of that last row, this is no solution. Because what this is saying 0x plus 0y plus 0z equals 1. So it's saying 0 equals 1, which is false. So that means there is no solution to that matrix then. Okay, so those are two things that can happen. Not going to worry about the all real number case like that. So you want to know how to use your calculator to do Gauss-Jordan elimination. Reduce row echelon form. Okay, next page, going to do a application here of a matrix. Okay, and again, word problem, you got to read, you got to figure out the variables, figure out the equations. Okay, so I'm going to read this. It says Mary pays $34 for 2 pounds of apples, 1 pound of berries, 4 pounds of cherries. Okay, that seems to be a piece of information, and it already sort of shows you where those three variables are. Tom pays $35 for 3 pounds of apples, 2 pounds of cherries, and 2 pounds of berries and 2 pounds of cherries. That's more information. Lee pays $49 because he goes to a high-priced store, I guess, and he gets that. Okay, so the question always tells you what the variables is. What is the price per pound for each of those three things? So I'm going to set this up. I'm going to say let X be the price per pound for apples. And actually, I'm going to use a sensible variable. I mean, to me, it doesn't matter. I'm just going to say A for apples. Then I'm going to go B for berries. So that's going to be the price per pound for berries. And let's see, C for cherries. That's going to be price per pound for the cherries. Okay, then this goes like this. The system goes straightforward like this. Okay, you're going to buy 3 pounds of apples, 2 pounds of berries, and 2 pounds of cherries, and that's going to cost $35. Okay, and all that's saying is you would find the price per pound of each of those. That would give $35. Okay, second equation I highlighted in blue is saying 3 pounds. Hold on, I think I didn't read the first sentence. Okay, let's go to the one I highlighted in yellow. That says 2 pounds of apples, 1 pound of berries, 4 pounds of cherries, adds up to $34. The second one says 3 pounds of apples, 2 pounds of berries, 2 pounds of cherries, that's $35. And then the last one says 5 pounds of apples, 3 pounds of berries, 2 pounds of cherries is equal to $49. So that's your system of equations. Again, we're going to do this on the calculator. So the augmented matrix goes like this. We'd have first row 2, 1, 4, 34. Second row 3, 2, 2, 35. Third row 5, 3, 2, 49. We're going to put in the calculator and do reduced row echelon form. All right, so I'm just going to type over what I had then. Okay, so I'll go second to matrix, edit, and just type over. This is a 3x4 matrix. So the first row is 2, 1, 4, 34. Second row is 3, 3, 2, and 35. Next row is 5, 3, 2, and 49. Okay, so that's the matrix, which is now put in. And then we're going to just use the calculator to put that in reduced row echelon form. Okay, so I've got that. Now, clear screen, second matrix, math, reduced row echelon form, matrix A, and that gives the answer to the problem. Okay, all right, and then that'll give you the answer to the problem. That's real easy to tell you're right, and I'll show you how you can tell you're right on this also. So basically, this is your reduced row echelon form: 1, 0, 0, 0, 1, 0, 0, 0, 1. That's what we expect. 7, 1.6, 4, 6. Okay, so again, this is the apples, because that column is apples, this column is berries, and then this column is cherries. Okay, so that would be your apples. So what we would say is apples are $7 per pound. We would also say the berries are 1.6, so that would be $1.60 a pound. And then the last thing would be the cherries. So we would say the cherries are $4.60 per pound, like that. Okay, and that's it. All right. Okay, now I'm going to continue on here and go to the next part here. And we're going to do some logs, a log review on this. Okay, so I'll go ahead and do this then. So if you have a log, if you do exponential form, what you do, this is a log form. So remember, you just say 3 to the 4th equals 81. Same thing here. That's the base. That's the power. Remember, the answer to a logarithm is an exponent. Okay, the base is the small number, so this would be 16 to the 1/2 equals 4. Okay, if you do this backwards, it goes like this. Okay, these are exponential equations, so it goes like this. The exponent is always what the answer to a log is. The base is there. 25 goes there. It's just a matter of knowing how to rearrange the numbers. This one goes like this. The answer is the exponent. The base is what you're raising, is what is being raised to the exponent. That's how you write that in exponential form. Okay, so you want to definitely know how to put that together. Okay, now we're going to do these logarithms. Now what you can do on this, you can do these in your head. What I usually show students to do is to think through this. Just set it equal to x. Set this, change it to exponential form. So we would say 5 to the x equals 25. Now do it in your head. Or you could use your calculator to help you if you had to. 5 to the second is 25. Okay, again, 5 to the second is 25. So the answer to that log is 2. Okay, this one you can go like this. Log base 9 of 9 equals x. 9 to the x equals 9. So what power of 9 is 9? That answer is 1. You can do these in your head if you want to. Okay, the next one I'm going to say log base 10 of 1 equals x. Exponential form, we say 10 to the x equals 1. What do you raise 10 to get 1? That's 0. And so you can double check anything you want to on your calculator. So if you did 10 to the 0 power, like that gives you 1. Okay, same thing here would be 5. The answer to the next one's 5 because 2 to the 5th is equal to 32. All right, so you can kind of go backwards with that on your calculator. You can just say 2 to the x is 32. X has to be equal to 5. Okay, now I'm going to review solving log equations. So the first thing you got to do on this is put this in exponential form. So we say 8 to the x equals 64. You do this on the calculator if you need to, or you can do it in your head. Okay, hopefully most of these you can do in your head. So the answer on this is x equals 2 because 8 to the second is equal to 64. Okay, next one I do the same thing. I go 3 to the second equals 3x minus 7. Whoops, not 3x minus 7, 2x minus 7, sorry. And you solve the equation. 3 to the second's 9. And then it's a matter of isolating the x, so we can add 7 to both sides. That would give 16 equals 2x. Divide both sides by 2, you get x is equal to 8. Okay. Okay, so those are two just standard type of exponential equations that you solve. Okay, next one you got to use log properties on. You have to remember a couple of things. We have log base b of m times n is equal to the log base b of m plus the log base b of n. The other property you want to know is the log base b of m over n. You subtract the log. So you say log base b of m minus log base b of n. Okay, like that. So the way these get put together then is like this. You say, with this, you got a plus sign, so you use this property here. So you would say log base b of x plus 2 times x is equal to the log base b of 24. Okay, now we have another property of logs that says if you have a log base b of x equals a log base b of y, then you can take off the logs and just set those things equal to each other. So you would have the equation x plus 2 times x is equal to 24. Okay, do a distributive property. That would be x to the second plus 2x equals 24. This is a quadratic equation. So you want to get one side equal to 0. So move that over there to get x squared plus 2x minus 24 equals 0. And then you want to solve this by factoring. Okay, so draw your two parentheses. And this goes like this. Okay, the first term is x squared, so that would be x and x. The last term is 24. The possibilities are 1 and 24, 2 and 12, 3 and 8, or 4 and 6. 4 and 6 is the right choice because they're 2 apart. So 4 and 6. To get a plus 2, you need to have plus 6 and minus 4 like that. So now you solve these two equations. You have x minus 4 equals 0. So that would give x equals 4. You have x plus 6 equals 0. That would give x equals negative 6. Now one of those answers does not work, and it's this one. The reason is you cannot do a logarithm of a negative number. So the only answer to this problem is this. All right, so that's how that gets put together. Okay, next problem, we're going to use this property, this second property. So we say log, and this is a base 10 log. Okay, and then we'd say the first x minus 1 over x plus 1 is equal to 1. So you're going to solve this equation, so we do this. We'd say 10 to the first equals x minus 1 over x plus 1. Okay, so that's going to give me 10 is equal to x minus 1 over x plus 1, and you want to solve that equation. The way you solve this equation is you get rid of the fraction. Okay, so what I'm going to do is multiply both sides of this equation by x plus 1, and that will get rid of the fraction. Okay, so what I end up with is 10 times x plus 1 equals x minus 1, and then I can solve that equation. So I'm just going to do this down here. I think I got room. That would be 10x plus 10 equals x minus 1. I'm going to move the x to this side, so I get 10x minus x equals negative 1. I'm going to move the 10 to get minus 10, so that's 9x equals negative 11. Divide by 9. It's okay if you get a fractional answer, so you would end up getting that as your solution. Okay, that's how that would work out. Okay, next thing I'm going to review is Venn diagrams and go over that a little bit. So with this one, we have students are enrolled in English and math. So we want to know what all these numbers represent. So in this one, this is the intersection. Okay, that's both. So that would be there's 7 people in the intersection. Those are people taking both English and math at the same time. The number of people taking English would be this whole entire circle, see? So that whole entire circle would be, you would have to do 18 plus 7 to get 25. And then the number of people taking math would be everybody in this circle. So that would be 7 plus 10. So that would be 17 people enrolled in math. And then the union is all of this together. So the union would be 18 plus 7 plus 10. So let's see, that would be 25, that would be 35 then. And then this is the universe. So it would just be all those numbers added together. So the universe would be 18 plus 7 plus 10 plus 5. So that ends up being 40. So you want to know what each of these numbers represents in a Venn diagram, okay, and what the symbolism means. Okay, on the next page, we're going to draw a Venn diagram. So let's read this first of all. So what this one says is out of a total of 150 people at a restaurant, 93 choose coffee, 47 choose juice, and 25 chose both coffee and juice. Okay, so what we're going to do is we're going to draw a Venn diagram on this. Very similar to the last problem. So we're going to do 2 intersecting circles and label one of them coffee and one of them juice. Okay, and I'm going to set these up so that they overlap. Kind of hate it when it does that. Come on, grab the sucker. There we go. Okay, all right. So I'll make them overlap. So I'm just going to say C for coffee and J for juice. Okay, the key thing is both would go there. So the 25 goes there. All right. Now what goes here is it says 93 chose coffee. So the 93 does not go there. You have to do 93 minus 25. You can do that on your calculator if you want to. So that is 68. So the 68 goes there. And then it says 47 chose juice. So you don't put 47. You do 47 minus 25 to get 22. So that goes there. Okay, that would be, notice that 25 and 22 are all the people doing juice. 68 and 25 are the 93 that are doing coffee. And then the universe is 150 people. So what we'd have to do is 150 minus the 68, minus the 25, minus the 22 would be what's left over. Okay, so I'm going to take my calculator, 150 minus 68, minus 25, minus 22. So that would be 35 left over. So that would be outside right there. All right, so what we're going to do is we're going to answer questions about this then. So it says, how many people chose coffee but not juice? Okay, that would be these people right here are the people who had a cup of coffee, but they didn't also have juice. So that would be 68. Then this says how many people chose juice but not coffee. That would be these people here. That's this piece of the circle. So that would be the 22 there. Okay, 22 had juice, but they didn't have coffee. Okay, so that would be 22. Then how many people had no beverage? Well, that would be those people. So 35 people didn't have anything. All right, so that's how you answer the questions about that. You want to be able to put that in and reason that out in a Venn diagram. Okay, next thing I'm going to review is probability and expected value. Okay, so this problem says 5 cards are drawn from a standard deck, which of course has 52 cards. Find the probability of drawing 5 red cards. Okay, now these are combinations. And remember, a combination order does not matter. Order no matter, okay? So we set this up like this. A probability, the denominator would be you are choosing from the 52 cards, you're choosing 5 cards. That's the grand total. What are you choosing? You're choosing 5 red cards. So 5 red cards, there are 26 red cards in a deck. So you're choosing a combination from that 26 like that. Now this right here, that's what you have to have on your paper. You want to have that set up. And then from here, we're just going to go straight to our calculator. And I'm going to do this in 2 steps. So I'm going to go 26, math, probability, number 3, combination, 5 at a time. That's going to give you how many possible ways there are to get 5 red cards. So that's 65,780 ways to get those 5 red cards. Then I'm going to do 52 combination, 5 at a time. That will be all the possible ways to get 5 cards. That's a big number. So that is 2,598,960. We're just going to round this off when we get the answer to a decimal. So 65780 divided by 2,598,960 will give that. And then we'll just round that off to maybe 3 decimals. Okay. All right, so I'm just going to round that then as 0.025. So it's a roughly around a 25% average when you do that then. Okay. Okay, next problem says you are drawing 7 cards from the 52. We're going to find the probability of getting 3 aces and 4 face cards. So this one goes like this. The denominator is all 7 of your cards are chosen from 52. Okay, we got to do aces. Okay, we're drawing 3 aces. How many aces are in a deck? There's 4 aces in a deck. Okay. Face cards. Okay, now aces and face cards are different, so there's no intersection, so we don't have to worry about that. There are 12 face cards in a deck, and you're choosing 4. The face cards are Jack, Queen, and King. So that's what you want to work out. Again, we'll do this on the calculator. So this will go like this. I'm just going to do them one at a time. 4 combination, of 3 at a time. So that's 4. Okay, so that gives 4 there. There's 4 aces. And we're drawing from 3. Okay, then I'm going to do 12 math probability combination 4 at a time, 4 face cards. So there's 495 ways to get that. And then the denominator, we do 52 math. Combinations, 7 at a time. That'll be a real big number. So that's 1, 3, 3, 7, 8, 4, 5, 6, 0. So that's over 133 million. Okay. Then I'm going to put this in the calculator just like this in one step. 4 times 495. And then divide by the big number 133, 7, 8, 4, 560. And that'll give the probability. And you can write that in scientific notation. That's a pretty low probability on that then, is what you'll have. Okay. All right, so that one, again, you can move the decimal back 1, 2, 3, 4, 5 to get 0, 0, 0, 0. So it would be about 0.000015 would be a super low probability on that. Okay, so that's how you do that. There's three cards are chosen from the 4 aces in the deck, and the other 4 are chosen from the face cards. So that's how that one gets put together. Okay, the next one says that you're drawing a single card, so it's not a combination, and we're just doing the probability of an ace or a spade. Okay, so what I'm going to do is I'm going to do this. I'm going to say probability of ace or, and remember or is union, so we're going to do this. The formula is probability of ace plus probability of spade minus the probability of both, or the intersection. Okay, there are 4 aces in a deck out of 52. There are 13 spades in a deck of 52, but there's only 1 ace of spades. Spade goes like that. Okay, so that would be minus 1 out of 52. Okay, so we do 4 plus 13 is 17. 17 minus 1 is 16 out of 52. You can reduce that fraction on your calculator if you want to, or in your head. So 16 divided by 52 is going to give you a decimal. You can go math, fraction. So that would be about a 4/13th probability. Okay, so there's a difference between when you draw more than 1 card, it becomes a combination. But if you're only drawing 1, it's a basic probability. Or probability, you always use this formula. Okay. Next page is again single card drawn from a standard deck of cards, the probability of drawing an ace and a spade. Well, that's easy. There's 52 cards. There's only 1 card that is both an ace and a spade. So that would be a 1/52nd combination. Okay, more probability. Number 17. What I'm going to have on this is, says a ping pong ball contains numbers 1, 2, 3, 4. It's not a bad idea to just write it out so you visualize this okay. So it goes like this. So we're going to find the probability of drawing a ball that has an even number. Okay, we're only drawing one ball, so there are 1, 2, 3, 4, 5 even numbers out of the 10 balls. So that's a 1/2 probability. Okay, next one says find the probability of a prime number or, and that's a key, that's a union divisible by 3. So I'm going to write it like this: probability of prime union divisible by 3, and then apply the formula. So you do the probability of prime plus the probability divisible by 3, and then minus the probability of both. You look for things that are both prime and divisible by 3 at the same time. Okay, so the prime numbers are going to be 2, 3, 5, 7. That's it. Everything else has more than 2 factors. So there are 4 prime numbers out of 10. Divisible by 3 is going to be 3, 6, 9. So there's 3 numbers divisible by 3. But how many are both? Just the 3. Okay, so that's 1/10. So you would have 7 minus 1 is 6/10. That fraction reduces to 3/5 then. Okay, so that's how you do that probability. All right. Okay, next thing we're going to do is probability tree Bayes theorem. I'm going to do this a couple of times, okay? All right, so this says 40 boys, 60 girls were surveyed, 30 boys voted for candidate A, while 50 voted for 50 girls voted for candidate A. And we're assuming that there's 2 candidates. We're also going to assume that there's a candidate B, okay? Or we're just going to say they didn't vote for candidate A. So when we do the probability tree, we start this like this. We're going to branch out into 2 directions. First of all, we're going to have a boy or we're going to have a girl. Okay, so if you look at the probability, there's a total of 100 people in here, with 40 being boys. So I'm just going to write this as 40. There's a 40 out of 100 chance that it's a boy, and then there's a 60 out of 100 chance that it's a girl. You can change these to decimals if you want to, and I'm going to do that as I do this. So this is going to be 0.4, and that's going to be 0.6. So the key thing is those individual probabilities should add up to 100%. Then we're going to branch out to candidate A, and then not voting for candidate A. Same thing here, girls. They voted for candidate A or they didn't vote for candidate A. So if you read this, it says 30 boys voted for candidate A. Okay? So what that probability would then be would be out of the boys, and remember there's 40 boys, you would have 30 out of 40 boys voted for candidate A. And that is 75%. So that would mean that 10 out of 40 voted for the other candidate or didn't vote. That would be 0.25. Okay, so that goes like this. Okay, then we'll do the same thing with the girls. It says 50 of the 60 girls voted for candidate A. So this is 50 out of 60. And I'm just going to round that off. If you go 5, 6, I'm going to round this off to 2 decimals because you can use a decimal on this. So that's 0.83. And then that would mean 10 out of 60. So if you just do 100 minus 83, that would be 17 left over. So that would be about a 0.17 probability like that. Okay, so that's how the probability tree goes. And a couple of things you want to notice on this. 40 of the 100 were boys, 60 out of 100 were girls. Those 2 probabilities add up to 100%. 30 of the 40 boys voted for candidate A, the rest didn't. So 75%, 25%. 50 of the 60 girls voted for candidate A, that's 0.83. The rest is 83%, 17%. Now that's your probability tree. Now what we're going to do on this is we're going to put together the probability. So this says if one person in the group is picked, we're going to use Bayes' formula to find the probability that the person is a girl given they voted for candidate B. Okay, or in other words, the other candidates. So I'm going to write this like, actually I'll write this kind of that as like A prime. Okay, so this is going to be the probability that they're a girl given that they voted for A prime. Okay, so first of all, what you have to do is the denominator is going to be the two different ways to get through a candidate to get to A prime. There's two ways to get to A prime. There's that way and there's that way. So the denominator is going to be this. It's going to be 0.4 times 0.25 plus 0.6 times 0.17. Okay, but the probability of a girl is only going to be going this way. That's a girl who also voted for A prime. So that would just be 0.6 times 0.17. So that's how Bayes' formula goes. I'm going to use my calculator. I'm going to go 0.6 times 0.17. So that will give 0.102 on the calculator. The bottom, I do 0.4 times 0.25 plus 0.6 times 0.17. That will give 0.202. Then I can just do this on the calculator. 0.102 divided by 0.202 is going to give about 0.50495. I'll just round this off to it's about 0.504. So it's a little bit more than 50% chance of that happening. Okay. All right. Now the next one is going to kind of go like this. So this one says the probability the person is a boy given that they voted for candidate A. So we're doing probability of a boy given candidate A. Okay, how are the ways to get to A? The ways to get to A are this way and that way. So your denominator is going to be this. It's going to be 0.4 times 0.75, kind of the green route, or 0.6 times 0.83. And then the probability of a boy given A would only be this route, so that would be the 0.4 times 0.75. Okay, we go to the calculator, so 0.4 times 0.75 is going to give 0.3 there. The denominator, 0.4 times 0.75 plus 0.6 times 0.83 is going to give 0.798. Then take your calculator, we'll round to like 3 decimals. 0.3 divided by 0.798 is going to give about 0.7376. Okay, so that's how you do that. Once you get the probability tree put together, then you look at where the branches are. So the given part, there's going to be probably two ways to get to A. Those are the two green branches I worked through there. That's kind of what that is. And then there's the one way to get to B. The only way to get to that you're a boy and A, you're going through the boy and through A, would be 0.4 times 0.75. So that's how you do a Bayes theorem example. Okay, now I'm going to go to expected value. So this is a payout table, and we're going to do the expected value. So remember, when you do expected value, you just multiply. You do 50 times 0.01 plus 5 times 0.09, and then negative 10 times 0.90. You want to notice that these probabilities all add up to 100%. And you can do this in one step on the calculator if you want to, like this. So I'm just going to go $50 you win with a low probability of 0.01 plus $5 times a higher probability of 0.09, and then minus 10, you lose money, times a high probability of losing money, so you end up getting this. So that expected value would be negative $8.05, which means you lose in the long run. If you kept playing that game, you would lose in the long run, and you would lose on the average about $8.05. Okay, next problem's the same thing, except you got to put it together. All right, so I'll read the next problem. this goes like this. This says a spinner is numbered 0 to 5, and each of the 6 numbers is equally to like come up as the other. I'm just going to write them up. We have 0, 1, 2, 3, 4, 5, 6. Okay? And it says a player who bets $1 will, on any given number, they will win 4 if the pointer comes to rest on the chosen number. Otherwise, a dollar bet will be lost. Okay, so here's how the payout table would go, is like this. All right, what you always do is you have the variable x and you have the probability of x. Okay, there's 6 balls. The probability of winning would be that you just choose the correct one. And that would be, if you choose the right one, you would just have a 1/6 probability then. So it goes like this. It says that you're going to win $4, and that would be 1 correct ball out of 6. So that's a 1/6 probability. Then it says you're going to lose that dollar otherwise. Okay, so you lose $1, and that would be a 5/6 probability. So that's all you're going to have on your payoff table, is you $4 if you choose the right ball. You lose $1 if you don't. Okay, so notice those probabilities add up to 1. So the expected value is going to be 4 times 1/6 plus -1 times 5/6. You could certainly use a calculator. If you do that, you would get 4 over 6. 4 over 6 minus 5 out of 6. Okay, so if you do that, you would have a -1/6. So you lose money in the long run. So is it a fair game? No. It's only a fair game if it's fair if the expected value is 0. Okay, so that's how you do that. Okay, so let's see. Now we're going to finish with finance. A lot of the finance, you got to know the right formulas to utilize. Okay, so this one, and then the TVM solver. So this one says if you invest $10,000 at 5.5% compounded quarterly, how long will it take for the account to reach $15,000? So this has nothing to do with TVM. It's only going to have to do with TVM if you're talking about an annuity, future value, present value, that kind of thing. So this is compounded quarterly, so it's the compound interest formula, which is A equals P, 1 plus R over M to the MT. And you got to know what everything means in that problem. So in this problem, P is what you're investing. That's $10,000. Okay, R is the interest rate, 5.5%, and you're going to change that to 0.055. M is the number of times you compound, so quarterly is 4. The time we don't know. It says how long, so that's what we don't know. Okay, the amount is what we're going to reach, is $15,000. So I always recommend write down the formula you need, write down what you're given. So when you plug this in, you're going to have 15,000 is equal to 10,000 times 1 plus 0.055 over 4 to the 4t power. Okay, then we got to solve this equation. You got to solve this with logarithms. So what I'm going to do on this is, the first thing that you want to do before you do logs, you want to use logs because the exponent is the unknown is an exponent. So the first thing we're going to do is we're going to divide both sides by 10,000. Okay, I'm going to take my calculator, and you can just kind of calculate. It's a good idea to round at the very end of the problem. So you could go, if you wanted to, 15,000 divided by 10,000, and just write down whatever decimals come out on the calculator. In this case, it's just 1.5. So I have 1.5 is equal to, and then if you want to do this, you can. You could go 1 plus 0.055 divided by 4, or you could wait till the end of the problem if you want to. That's up to you. I'm just going to go ahead and do that. So I get 1.01375 to the 4t power. Okay, now I'm ready to do a log of both sides. You can do a log or an ln. It doesn't make any difference which one you do. I'm going to do ln. You'll get the same answer regardless. Okay, when you do a log, we're allowed to bring that exponent in front. So you would have ln 1.5 is equal to 4t times ln 1.01375, like that. Okay, then you can divide. So you're trying to get t by itself, so you divide both sides by 4 ln 1.01375. Then you're going to go to your calculator, but you have to be really careful about how you put this in your calculator. Okay, so that goes away, that goes away. You've got t. Now watch how I put this in the calculator. Okay, what I have to do is I have to go ln 1.5, close parentheses, divide by new parenthesis, 4 ln 1.01375, and then close parentheses. So that goes like that. And then the answer would just be rounded. We'll just say about 7.4 years would be the answer of the problem. All right, so that's how that goes. You're using the compound interest formula. Okay, next page. All right, a couple other pages to go. And let's see, this one says inflation is at a rate of 1.5% per year compounded continuously. What will you pay for a $50,000 item in 5 years? So the first thing is, this is the PERT formula, PERT shampoo, I always call it. P equals E to the RT. Okay, in this problem, the interest rate is 1.5%. And then the amount of money, the P. Oh, hold on, I wrote the wrong thing. That's not the formula. Shoot, it goes like this. A is equal to P E to the RT. So in this problem, 50,000 is the original amount, and then T is the 5 years. Okay, so really all you got to do on this is just plug in the formula. So you would have 50,000 e to the r, 0.015, change the decimal, multiplied by 5, and just go straight to the calculator. Do that in one step. Okay, so this would go like this. Easiest way to do this to me is go 50,000, second ln, and then put in 0.015 times the 5, and it'll give the answer, and then we'll just round that off. So that is going to inflate to $53,894.21. So that price has gone up by that inflationary rate. All right, so that's the answer of the problem. Okay, the next problem says find the amount in a savings account if $500 is deposited at 2.8% simple interest after 18 months. So the simple interest formula, there's two of them. I equals PRT, and there's A equals P times 1 plus RT. In this problem, what we have is P is the principal. That's what we're depositing. The interest rate is going to be 2.8%. And then the time is going to be 18 months, but you have to divide that by 12 to get that in years. So 18 divided by 12 is 1.5, so that's 1.5 years. So you got to make sure that that's in years. Okay, we don't know what A is. So the best thing to do is to use this second formula. So we just plug in. We would have A is equal to the principal, 500, times 1 plus the interest rate, which is 0.028, times the time, which is 1.5 years. And again, you can do this pretty well in just one step on your calculator. More steps if it's helpful to you. And go like this. So I'll go 500, parentheses, 1 plus 0.028 for the interest, times 1.5, close parentheses, and then that will give about $521. Okay, so if it has to do with simple interest, you want to use that formula. Okay, next problem, ordinary annuity. Okay, so when you talk about ordinary annuity, then you got to talk about the TVM solver. You don't necessarily have to know that formula to use it. You can just use the TVM solver. Okay, so what I'm going to do is I'm going to write down the formula that we learned for the value of an ordinary annuity is like this. Okay, future value equals the payment times 1 plus R over M to the MT minus 1 all over R over M. You can do that, or you can do the TVM solver. So what I'm going to do is just set up the TVM solver and kind of show you how that goes in. Okay, so you can plug into that formula if you want to. So basically what we want to do on this is you want to go Apps, Finance, TVM solver. You want to get there. Okay, so in this particular problem, what you want to have, if you want to do the TVM, just write down what you're doing. N, I percent, present value, payment, future value, payment per year, compounding per year, and make sure that that payment is on end. Okay, like that. Okay, so it says you deposit each month. That is your payment. You typically want to use a negative number for the payment. If you do, you'll end up getting a negative answer. So just ignore negatives when you do that. Okay, then it says 6%. So the interest is 6%. Just put 6 in. You're compounding monthly now. So, and you're doing this for 20 years. So you're making payments 12 times a year times 20. So you want to put that in like that. The present value is 0 because your annuity starts at $0. Future value, that's what you're trying to find. Payments per year, there's 12 payments per year, and you're compounding 12 times. So when you put this in, 12 times 20 is going to tell you that you're doing 240 payments. Okay, we want to put in 6%. Don't move the decimal back. Present value is 0. Payment, you're making $250 payments. Future value, you don't know, leave it alone. 12 payments per year, compounding a year like that. Okay, so that's how you want to get that put in. Originally is like that. Then you want to do this. Since we're finding the future value, scroll over it, get it blinking, and then go alpha, solve, and then that will give the answer of the problem. So see, it's real easy to just use the TVM solver. All right, so this would be the amount that's in the annuity like that. So what we would have is the future value would be this amount. Now, if you plugged this into the formula, it'd go like this. Your payment would be $250, 1 plus the interest rate, 0.06, over compounding monthly. That whole thing is to the 12 times 20 years minus 1 all over 0.06 over 12. So if you want to set it up, you go that way. But the answer to that problem is just going to be the future value is 115,510 and 22 cents. So that would be your answer to the future value. Okay, now the question is how much interest got earned on this? So what you want to do is you want to do these two things. The first thing you want to do is your payments. We're going to figure out the amount of money in your payments. So what we're doing is we're doing 240 payments times $250. Okay, so I'm going to do that on the calculator. So if I do 240 times 200, whoops, I'm doing 250 payments of $250. Okay, so you are putting in $60,000. Okay, so that's what you pay. Okay, well, you ended up with this amount. So what you do is the interest is going to be $115,510.22. minus the amount of money you put in. So that would be the interest earned. Just do that on the calculator. And what you'll get on this is $55,510.22. Okay, so that would be the answer to the second part of that problem. All right. Okay, next problem is a present value. So again, we're talking about an annuity, so we're going to use the TVM solver to do this. Okay, all right, so I'm going to load up TVM. Again, it's App, Finance, TVM. And we're going to write down everything that we have on here in this problem and use the TVM to do this. I am going to write the formula down too in case you want to do it that way. Because you can do it either way. It's just easier to do it with the TVM solver. Okay, so the present value of an annuity goes like this. PV is equal to PMT. This formula is given on the exam. 1 minus 1 plus R over M to the negative MT all over R over M. That's how you find present value. So anyway, in this problem, if you read what you have here, 250 are deposited annually, so your payment, use a negative number. Annually means you're doing one payment per year and you're compounding one time per year. Okay, so the present value of an ordinary annuity, you're putting that money in, and then the interest on this is 3%, so that goes there. The payments, you're doing one payment a year times 20, so you're doing 20 payments there. Okay, so what's going to happen is we're going to find the present value of the ordinary annuity for 20 years at a rate of 3% compounded annually then. Okay, now in this particular thing, what you're going to have is you're going to start off on this on the present value. That's what you're trying to find. So you're not given anything. We're just going to start the future value at 0. Okay, so what we'll do on this, and you can go through the formula to get the same answer if you want to. We're just going to put in 1 times 20, or just put 20 in. You have a 3% interest. Present value, leave it alone. Your payments are negative $12.50 per year. Okay, future value. Remember, we're kind of like doing a loan, and that loan is going to be paid off. So you can think of, you know, something being paid off. All right, 1 per year and 1 compounding per year like that. So you want to get that set up like that initially. And then what you want to do is go to present value, get the cursor blinking, go alpha solve, and then that'll give you your present value. Okay? So that would be kind of like, you can think of that kind of like a loan amount that you're doing on that then. Okay, so what we'd have is you would get this answer. If you wanted to use the formula, you would go like this. You would put in $12.50, and then 1 minus the interest is 0.03, compounded annually. Oops, I got that in wrong. So go like this. Your formula would go 1 minus parentheses, 1 plus 0.03 over 1 to the negative 1 times 20 years, all over 0.03 divided by 1. And you should get the same answer on that. So if you do that, the answer is going to be this. So that would be kind of like a loan amount of $18,596.84. Okay, so that's how that gets put together. Okay. Okay, last page. Finish this up. More TVM, I think. Okay, so this says you purchased a home, $450,000. You made a 20% down payment, interest rate, compound monthly, like this. So if you're talking about payments, you're talking about a TVM solver. Okay, so this is going to go like this. Again, I'm going to load up the TVM solver, and we'll write down what we're doing. If you want to use the TVM on your test, you just write down what you have put in. Okay, like that. So let's get everything put in. All right. So to begin with, on the problem, you are making monthly payments for 20 years. So or 30 years. 12 payments per year times 30, that will give you 360 payments that you are making. The interest is 3.5. Don't move the decimal, just put it in. The present value, just leave it alone. Put anything in there you want to, okay? Or I'm sorry, put that in as 0. So you start at the present value, okay, like that. Your payments are, that's what you're trying to find. Oh, first of all, what we got to do the down payment. So I didn't think about that. First step is figure out the down payment. So we need to do 450,000 multiplied by 20% to get the down payment. So 450,000 times 0.20 means that you're making a down payment of $90,000. Wow, that's big. Okay, so you're going to finance this amount. You're going to take the $450,000 price tag of your house minus the $90,000, so you're going to finance $360,000. Okay, so when we put this in the TVM, it's going to go like this. We're going to do 12 payments a year for 30 years, 360. The interest is 3.5. The present value is where we're going to start our loan. So that loan is going to start at $360,000. Okay, like that. The payment, we have no idea what the payment is, so leave that alone. The future value you're going to have paid off. So you'll have that. Okay, and so future value 0, 12 payments per year, compounded per year like that. So that's how the TVM gets set up. Okay, to get our payment, you want to go to payment, get it blinking, and go alpha solve. That will give your payments. Okay. Okay, disregard the negative. Don't worry about that. So you would end up getting, after you put that in, 12 and 12. So your payments are $1,616.56. So those are your monthly payments, okay, on that expensive house. Now what we're going to do is find out how much do you pay over the term of the loan. Okay, well, you make 360 payments of $1,616.56. So you just multiply that out. 360 times 1616.56. You're going to pay a lot of money on this sucker. You're going to pay $581,961.60. If you never refinanced, never changed the interest rate, and made payments religiously like that, that's how much money you would pay. All right, that's it.